She straightened display cases and answered questions about vintage aircraft engines, until a computer screen showed her something that made her blood run cold. Commander Evelyn Sky Monroe had been volunteering at the National Museum of Naval Aviation for 3 years now. To most visitors, she was just another friendly face in a navy blue polo shirt, pointing out the differences between a Corsair and a Hellcat. Her graying hair was pulled back in a practical ponytail, and her comfortable walking shoes suggested someone who spent long hours on museum floors. But there were small signs for those who knew how to look. The way she instinctively checked wind direction when stepping outside, how her eyes tracked aircraft overhead with the precision of someone who had once depended on such awareness for survival. The small navy wings pin on her collar, not the tourist shop variety, but the real deal, slightly worn from years of wear. Most visitors never notice these details. They saw a pleasant woman in her late 50s who seemed to know an unusual amount about flight dynamics and carrier operations. What they didn't know was that before her retirement 5 years ago, Commander Monroe had logged over 2,400 flight hours, including 127 carrier landings in everything from training aircraft to FA-18 Super Hornets. On this particular Tuesday morning, Evelyn was preparing for a special event. The museum was hosting a demonstration for a group of young Navy pilots fresh out of flight school, along with representatives from Meridian Defense Systems, a contractor developing next-generation autonomous flight control systems. As she arranged chairs in the main exhibit hall, Evelyn found herself studying the faces of the young aviators. They reminded her of herself 25 years ago. Eager, confident, maybe a little too sure that technology could solve any problem. She remembered that feeling well, right up until the moment her FA-18's flight control system malfunctioned over the Pacific, and she had to bring her aircraft down onto a carrier deck using backup systems and hard-earned instincts. That incident had changed everything for her. Before that night mission in 2008, she had been like these young pilots, trusting in the sophisticated systems that made modern aviation possible. The FA-18 Super Hornet was a marvel of engineering with computer-assisted flight management that could handle situations faster than any human reflexes, until it couldn't. She still remembered the warning tone when the primary flight control system failed. Not a bang or explosion, but a subtle change in the aircraft's response that told her everything she needed to know. The stick felt different in her hands, and suddenly the computer screens that had been her trusted companions were showing caution indicators. The approach to the USS Nimitz that night had been conducted with constant radio communication with the landing signal officer, following emergency procedures step by step. The backup flight control system was functional but less responsive, requiring her to rely heavily on fundamental flying skills that no computer could replicate. What made it particularly challenging was the weather. A Pacific storm system had moved in, creating unpredictable wind conditions and reducing visibility. She had brought the Super Hornet down using techniques that combined modern procedures with old-school airmanship, reading the deck conditions, judging the approach by feel, and trusting in skills built over hundreds of previous landings. The successful landing that night had earned her recognition, not just for technical skill, but for the calm decision-making under pressure that separated good pilots from exceptional ones. The Meridian team was setting up their equipment near the restored F-4 Phantom. Their presentation featured something called the Adaptive Flight Management System, AFMS for short, designed to handle complex landing scenarios autonomously. The young project manager, an earnest-looking man named Dr. James Chen, was explaining to the pilots how the system could compensate for carrier deck movement, crosswinds, and even equipment malfunctions. The beauty of AFMS, Dr. Chen was saying, is that it processes multiple variables simultaneously: wind conditions, deck movement, aircraft configuration. It handles complex scenarios efficiently and consistently. Evelyn continued her quiet preparations, but her ears were tuned to every word. She had spent enough years in cockpits to know that when someone claimed their system was foolproof, they usually hadn't tested it against the right kind of problems. The demonstration began with a simulated carrier landing scenario. On a large monitor, the AFMS was controlling a virtual FA-18 through its final approach to a carrier deck. The system smoothly adjusted for a slight crosswind, corrected for deck movement, and appeared to be executing a textbook landing. Evelyn watched from the back of the group, her trained eye following the data streams on the auxiliary monitors. Wind speed, direction, aircraft attitude, descent rate, all the numbers that had once been critical to every landing. That's when she noticed something unusual. The wind readings showed a steady 15-knot wind from the port side, but the AFMS correction algorithms seemed to be making adjustments that didn't quite match the displayed conditions. The error was subtle, maybe a degree or two of difference, but Evelyn had seen enough deck landings to know that small errors could compound quickly. She stepped closer to the monitor, her pulse quickening. The system appeared to be using wind readings from the wrong reference point in its calculations. It was processing the data correctly, but from a perspective that would be slightly off during actual landing conditions. "Excuse me," Evelyn said quietly, approaching Dr. Chen. "I think there might be an issue with your wind reference calculations." Dr. Chen glanced at her with polite interest. "I'm sorry, ma'am, but this is a technical demonstration. The system has been extensively tested. Your system seems to be using a fixed wind reference," Evelyn interrupted gently. "But during actual carrier operations, wind conditions can shift rapidly. The correction algorithms might not adapt quickly enough." A young pilot next to her smiled. "Ma'am, these systems are designed to handle changing conditions. They're pretty sophisticated." Evelyn looked at the simulation, then at the confident faces around her. She had been in this position before, the outsider pointing out potential problems that no one wanted to hear. But she had also been in enough cockpits to know what happened when people ignored subtle warning signs. "Could you run the simulation again?" she asked calmly. "But this time, add a wind shift during final approach? Nothing dramatic, just a normal operational condition." Dr. Chen hesitated, then looked at his team. "We weren't planning to test dynamic wind conditions today." "It's a routine flight condition," Evelyn said. "Any carrier pilot will tell you that deck winds can change during approach." The young pilots exchanged glances. Finally, Lieutenant Sarah Martinez, one of the newer aviators, spoke up. "She's right about the wind changes. We deal with them regularly." Dr. Chen reluctantly programmed a moderate wind shift into the simulation. The virtual FA-18 began its approach again, the AFMS making smooth corrections for the initial wind conditions. Then at 400 feet above the deck, the wind shifted 6 degrees to starboard. For a moment, the system continued normally. Then gradually, the aircraft began tracking slightly left of centerline. The AFMS made a correction, but it was delayed and insufficient. The virtual FA-18 continued its drift, approaching the edge of the safe landing zone. "That's not quite right," Lieutenant Martinez observed, her professional training kicking in. The room grew quiet as everyone watched the screen. The virtual aircraft managed to catch the arresting wire, but it was clearly outside the optimal landing parameters. Dr. Chen stared at the screen, his confidence shaken. The system should have compensated faster. "Wind reference points matter," Evelyn explained calmly. "The algorithm needs to account for where the wind measurement is taken versus where the aircraft actually is. It's not just about processing the data, it's about understanding what the data means in real conditions." The young pilots were studying the display now, their earlier casual confidence replaced by professional interest. Lieutenant Martinez turned to Evelyn. "Ma'am, how did you spot that so quickly?" Evelyn smiled slightly. "I've made quite a few carrier landings over the years. You learn to pay attention to the small details when you're trying to put an aircraft down on a moving deck." Dr. Chen was already making notes, clearly recognizing the importance of the feedback. The demonstration had revealed a potential issue that could be addressed before the system moved to actual flight testing. As the group dispersed, Lieutenant Martinez approached Evelyn. "Ma'am, I'm sorry we didn't take your input more seriously at first. May I ask about your background?" "I used to fly," Evelyn said simply. "Spent most of my career in naval aviation." "What kind of aircraft?" "Mostly FA-18s, some training aircraft. Whatever the Navy needed." She paused, looking up at the F-14 Tomcat suspended from the ceiling. "I was a test pilot for a while, then a squadron commander. Retired about 5 years ago." The young pilot's eyes widened as recognition dawned. "Commander Monroe, you're the pilot who helped develop some of the current carrier landing safety protocols, aren't you?" Evelyn nodded modestly. "I worked on a few procedures updates. Team effort, really." Word spread quietly through the remaining group of pilots. Commander Sky Monroe wasn't just a museum volunteer. She was a respected former squadron commander who had contributed significantly to naval aviation safety. As the museum returned to its normal quiet routine, Evelyn went back to straightening display cases and answering questions about vintage aircraft engines. But now, when she pointed out the differences between a Corsair and a Hellcat, people listened with a different kind of attention. Dr. Chen found her before leaving. "Commander, I want to thank you. Your feedback could prevent serious problems down the line." "Better to find issues early," Evelyn said. "That's what testing is for. Would you consider consulting on the project? We could really use someone with your operational experience." Evelyn considered the offer. "I'm happy here at the museum, but if you need someone to review your systems from a pilot's perspective, to ask the practical questions, well, I'm usually here Tuesday through Thursday." She walked back to her station near the entrance, her comfortable shoes quiet on the polished floors. To most visitors, she was still just another friendly face in a navy blue polo shirt. But among those who knew, word would spread. When Commander Sky Monroe looked at your system and offered feedback, you listened carefully. Because sometimes the most valuable expertise comes not from the latest technology, but from the quiet accumulation of knowledge earned one careful landing at a time. Every day, retired veterans like Commander Monroe walk among us, in museums, libraries, coffee shops, and community centers. They carry decades of experience that could prevent disasters, solve problems, and save lives. Yet their stories often go untold. Their wisdom, earned through years of service and sacrifice, deserves recognition. If you found Commander Monroe's story compelling and want to hear more about the unsung heroes who've served our country, hit that like button and subscribe to Echo Bravo. These veterans have incredible stories to share, and every subscription helps us continue bringing their experiences to light. What other hidden heroes might be volunteering in your community? Let us know in the comments below.